Hello, today's lesson is a continuation of simplifying radicals. One of the big differences that you're going to see today is we are not just going to be looking at square roots. We might be throwing in cube roots or fourth roots or fifth roots. The other thing you will see new is you will have variables involved. So let's take a look at some instructions. We're going to start by doing the exact same thing we've done in the past. We're going to break down the number using a factor tree until only prime numbers are left. Then we need to look at the root number. When I talk about the root number, what you will see is you will see a regular square root sign, but you will see a small number right there. For example, you'll see a 3. That's a cube root. You'll see a 4. That's a fifth root. And you'll see, that's a fourth root. And you'll see a 5. That's a fifth root. Those are the 3 other than the square root that we'll be doing today. There are other problems that have higher numbers. We're just keeping it small for our class. So what's important is this root number, the 3 and the 4 and the 5, they tell you how many of a kind to look for. When we were doing square roots, we looked for 2. We looked for pairs. We're no longer looking for pairs. If it's a square root, it's still pairs. If it's a cube root, it's 3. Fourth root is 4. Fifth root is 5. So the groups are getting larger. Just like before, you're going to cross them off in groups. And when you cross them off, it comes outside the radical as 1. The same thing is going to work with your variables. Then, just like before, all numbers that we bring outside and all numbers left inside, we multiply back together. So I don't want you to look at this right now and be confused. An example will help clarify it a little bit. So let's go ahead and look at the first pair of examples together. So our first problem here is a square root. There's no extra numbers. So I'm going to make a note. We look for pairs. So let's go ahead and start our factor tree. 24 is 4 and 6. 4 is 2 and 2. Those are primes. 6 is 2 and 3. Those are primes. The variables are a little different. We want to group them by 2's since we have pairs. So what I'm going to do with this A, I have 3 A's total. So 2 of them make a pair. That would be A squared. And there is 1A left over. I'm going to look at the B to the fifth. There are 5 B's here. Well, 2 of them make a pair. We have 3 left. 2 more make a pair. We now have 1 left. He's by himself. So now is when we start looking for those pairs, like I have mentioned right here. So with the numbers, we have a pair of 2's. I'm going to cross off those 2's. Outside the radical, I'm going to put a 2. The 2 and the 3 are extras. They go inside. Now the variables, the squareds are pairs. That's a pair. When I cross it off, 1A gets to come outside. 1A is left inside. The B's, that's a pair that I crossed off. 1B gets to come outside. That B, the next B squared is also a pair. Cross it off. 1B gets to come outside. There's still 1B left inside. So when we multiply them back together, we have a 2. We have an A. B times B is B squared. Inside, 2 times 3 is 6. We still have an A. We still have a B. That is our final answer. So I know it's very different. These are going to take maybe a little longer for you to catch on to. Let's take a look at the next example. First thing I want to point out, we have a cube root. You need 3 of a kind in order to come outside of the radical. So let's start with 72. 72, we know is 8 and 9. Got to keep going. 8, 2 and 4, 2 is prime. 4, 2 and 2, both primes. 9, 3 and 3, both primes. The x's. Since we want 3 of a kind, we want groups of 3s. Well, if I have 6, I definitely can make a group of 3. 6 take away 3 leaves me with 3 more. I can make another group of 3, and I've used all of my x's. The y's, I have 4 y's. I can make definitely one group of 3. 4 take away 3 leaves me with 1 y left. So now we start looking for, and here again, we're looking for 3 of a kind. So you're looking for groups of 3s. So I have 1, 2, 3 2s. Got to cross off 3 of them. So that means outside of the cube root, don't forget your cube, is a 2. These 2 3s, they don't get to come out because we need 3 for them to come out. So the 2 3s are going to stay inside. This x to the third gets to come out as a single x. This x to the third gets to come out as a single x. No more x's left over inside. This y to the third gets to come out as a y. The single y does not get to come out. He stays inside with the 3s. So our final answer, we have a 2 outside. X times x is x squared. We also have a y outside. Inside of our cube root, 3 times 3 is 9. And we have that y left over. There is your final answer. So hopefully you caught on to that a little bit. I would like you guys to look at example 2 and give example 2 a try on your own. So pause the video, try those, unpause, and you'll come back to see the answers. All right, so let's take a look at how you did. First of all, this was a square root. So we are looking for pairs. 96 is 2 and 48. 2 is prime. 48 is 6 and 8. 6 is 2 and 3, both primes. 8 is 2 and 4, 2 is a prime. And 4 is 2 and 2, both primes. Now we're back to pairs. So with the variables, we're looking for 2s. We have 8 A's. So we have one pair of 2s. That leaves us with 6 more. Another pair of 2s. That leaves us with 4 left. Another pair of A's. Sorry, those are A's. We have 2 left over. Another pair of A's. No more left over. We've used 2, 4, 6, 8 A's total. Let's look at the B's. We have 9 B's. So we can definitely make a pair. Take away 2, we're left with 7. We can make another pair. Take away 2, we're left with 5. Make another pair. Take away 2, we're left with 3. Make another pair. Take away 2, we are left with 1. No more pairs. Everything we're looking for is pairs. So, pair of 2s, put a 2 outside the square root. Pair of 2s, put another 2 outside the square root. The 3 and the 2 are left over. Those go inside. Let's look at the A's. Pair of A's, A goes outside. 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 No more A's left. Pair of B's, a B goes outside. Pair of B's, a B goes outside. Pair of B's, B goes outside. Pair of B's, a B goes outside. This B is extra. He stays on the inside. So let's look at our final answer. 2 times 2 is 4. We have a total of A to the 4th power, total of B to the 4th power. Inside the square root, 3 times 2 is 6B. Final answer. Let's look at the next one. This, I want to start by saying, that's a 4th root. So we're looking for 4 of a kind. That's very important. We are looking for 4 4 of a kind. Start with 64. 64, most people know, is 8 and 8. 8 is 2 and 4. 2 is prime. 4 is 2 and 2, both primes. 8 is 2 and 4. 2 is prime. 4, 2 and 2, both primes. Let's look at the x's. We are looking for 4s. So we start with 10. We have one group of 4. That brings us down to 6. We have another group of 4. That brings us down to 2. Can't make any more groups, so we have 2 left over. Let's look at the y's. We have 15 of them. We can make a group of 4. That brings us down to 11. Group of 4 brings us down to 7. Group of 4 brings us down to 3. We cannot make any more groups, so we have 3 left over. Now, we are looking for 4 of a kind. You need to be able to cross off 4 2s. So 1, 2, 3, there's 4 2s. So outside of our 4th root, don't forget the 4, is a 2. The other 2 2s must stay inside. Let's look at the x's. Group of 4, x outside. Group of 4, x outside. Group of 2 stays inside. Y's, group of 4, y outside. Group of 4, y outside. Group of 4, y outside. Group of 3 stays inside. So our final answer on the outside is a 2. X times x is x squared. There are 3 y's. Don't forget your 4th root. 2 times 2 is 4. And we still have x squared y to the 3rd. All right, so I want to do 2 more together because I want to show you an easier way of dealing with the variables, because this is a lot of work to show for letters, especially when you get into large numbers. So let's take a look at some easier ways to do the variables. So let's look at example 3 together. We are back to square roots, so we are looking for pairs. 81, 9 and 9, 9, 3 and 3, 9, 3 and 3, we're done there. So here's the easier way of doing the letters. X. Since we are looking for pairs, we're going to take the exponent, which is 4. We're going to divide it by, pairs means 2, and we want to see how many wholes and what the remainder is left. So 4 divided by 2 leaves you 2 wholes, remainder 0, because it goes in evenly. The y's, 6 divided by 2 gives you 3, remainder 0. The 2 and the 3 are how many goes outside. The remainder is how many stay inside. Hopefully that'll be an easier way of writing this for you. So, we are looking for pairs. Pair of 3's, outside the square root is a 3. Pair of 3's, outside the square root is a 3. So, this 2 and this 3 are important. The 2 means that we have x squared outside. The 3 means we have y to the 3rd outside. The remainders, since they are also important, the zeros tell you what is left inside. So there's 0 x's left inside, there are 0 y's left inside. This problem, the radical is gone. So 3 times 3 is 9. X squared y to the 3rd is your final answer. Let's take a look at B together. First of all, cube root means 3 of a kind. 125 is 5 and 25. 5 is prime. 25 is 5 times 5. Those are both primes. Let's look at the A's. We have 7. Since we want groups of 3 this time, we're going to divide by 3. That goes in 2 whole times with a remainder of 1. The B's, we have 12. We're looking for groups of 3. That goes in 4 times with the remainder of 0. So let's take a look at our problem. We are looking for 3 of a kind. So 5s. 1, 2, 3 5s. So outside of the cube root is 1 5. Let's look at the letters again. The 2 and the 4 tell us what is outside. There are 2 A's outside and 4 B's outside. The 1 and the 0 tell us that there is 1 A inside and 0 B's. So our final answer is 5A squared B to the 4th times the cube root of A. So now that we did 2 of those together, I'm hoping that your letters, that's a lot easier than trying to write them all out. Now go ahead, try example 4 on your own, pause the video, pick it up when you're done to see how you did. Alright, so let's take a look at A. First of all, 5th root means we are looking for 5 of a kind. 5, that's a lot. Start with 729. 729 is 3 times 243. 3 is prime. 243 is 3 times 81. 3 is prime. 81 is 81 is 9 times 9. 9. 3 and 3, both primes. And that 9. 3 and 3, both primes. Let's look at the letters. For the A's, we have 8. We are dividing by, we want 5s. So we're dividing by 5s to give us 1, remainder 3. The B's, we have 5. We're dividing by 5 to give us 1, remainder 0. So let's take a look at our answer. We're looking for 5 3's. 1, 2, 3, 4, 5 3's all come outside of the 5th root as 1 3. Let's look at the letters. The 1 and the 1 tell us what goes outside. There is 1 A outside. There is 1 B outside. The 3 and the 0 tell us what is left inside. There are 3 A's inside. And there is no B's inside. And I was jumping ahead of myself. And there is this little leftover 3 here that I totally forgot about that also goes inside. So the final answer is 3AB times the 5th root of 3A to the 3rd. Hopefully you got that right. Let's look at the very last example. Square root means we are back to pairs. 200, let's go the easy way, 2 and 100. 2 is prime. 100 is 10 and 10. The 10s, 2 and 5, both primes. 2 and 5, both primes. The x's, 12 divided by pairs means 2 is 6, remainder 0. The y's, 8 divided by 2 is 4, remainder 0. So we're looking for pairs. That's 2. 1, 2 2's. Outside of the square root is a 2. 1, 2 5's. Outside of the square root is a 5. The 2 here goes inside. Let's look at the letters. The 6 and the 4 are what goes outside. There are 6 X's outside and 4 Y's outside. The 0 and 0 tells you what is left inside. There are 0 X's inside and 0 Y's inside. So our final answer, 5 times 2 is 10, X to the 6th, Y to the 4th, square root of 2. So these are going to take a little more practice, a little more time. Hopefully you understood how this worked. If you would like to start on your homework, you're more than welcome to, but you will have homework time in class next time I see you.